So in this chapter, we are going to go through general principles of engineering mechanics statics. So this chapter is divided into 5 sections. In section 1, we're going to go through basic definition of mechanics, and also we're going to study some branches of mechanics, and also what is statics, what is dynamics, and how this subject fits into engineering mechanics statics. Section 2 would be on fundamental concepts. In fundamental concepts, we'll study basic quantities. We'll also understand how to idealize the bodies. And also we're going to go through Newton's 3 laws of motion and also Newton's laws of gravity. In section 3, we'll understand units of measurements, because quantities alone cannot give you a sense of the magnitude that what that thing is. So we have to understand the units of measurements as well. After understanding units of measurements, we're going to go through international system of units, method of prefixing, and in the end, we're going to also do some numerical calculations. So what is mechanics? Mechanics is a branch of physics that deals with effect of forces on bodies. So basically, we have two components of mechanics. You have forces and you have bodies. And studying the effect of forces on bodies is called mechanics. And mechanics have 3 branches, which is rigid body mechanics, deformable body mechanics, and fluid mechanics. So basically, this is the effect of forces on rigid body or deformable body or fluids. So what is a rigid body? Rigid body is an idealization of a body. So basically, it's a model of a body that does not deform or change shape. So basically, it's an idealization, or it's a simplification of an actual model that says that the object will not deform or change shape. So if any object that is not deforming or changing shape, then the study of effect of forces on that type of body would be studied under rigid body mechanics. Now, if a body can change shape or deform, then there are whole new set of rules which are applicable on this type of body. So the study of deformable body comes under deformable body mechanics. And there's another branch of mechanics which is called fluid mechanics, and that is concerned with the mechanics of fluids. So that investigate the effect of forces on fluid, and fluid can be liquid, gases, or plasma, among others. Now, we're going to focus on rigid body mechanics in this lecture series, and rigid body mechanics can also be divided into 2 sub-branches. One is statics and another one is dynamics. Now, statics deals with the equilibrium of bodies, and this is something we're going to go into a lot of detail in coming lectures. And dynamics study the accelerated motion of bodies. In this lecture series, we're going to focus on rigid body mechanics statics. So now let's go towards section 2 of this lecture, which is on fundamental concepts. And there are basically 4 things which we're going to study: basic quantities, idealization, Newton laws of motion, and Newton law of gravity. Now, what is basic quantity? Basic quantities basically are quantities which are used and which are very important in engineering mechanics statics. So I have presented some of the basic quantities which are very important in engineering mechanics statics subjects. There are other basic quantities as well, such as temperature and others, which are out of the scope of this lecture. So there are 4 basic quantities: length, time, mass, force, which are going to be extensively used in this subject. So what is length? We all have this understanding of length intuitively, but as far as the definition is concerned, we can define length as a straight line distance between 2 points. So basically, if you have 2 points, so the distance between these 2 points would be called length. But we all have understanding of length, what that length is. For example, if you are asking someone how tall he is or she is, then you're basically getting a sense of idea of the length. Or if you are asking like what is the length of this pencil, so basically you are trying to figure out the distance between these 2 points. So that's length. We also have a pretty good intuitive understanding of time, but in order to define time, time is defined as an interval over which succession of events occurs. So basically, we all have these understanding of time, but time is we can understand this as a passing succession of events. So there are events happening, and you can divide these events into intervals. So this interval over which the succession of events occur can be defined as time. But we all have this sense that what time is. Now, what is mass? Mass is basically an amount of matter in a body. So if you ask someone that how much he or she weighs, and if she says my weight is 50 kg, so basically you are trying to get a sense of the mass of that person. Now, force is also a very important basic quantity, which we're going to go into a lot of detail in coming lectures. But for the sake of definition, you can define generally as a push or pull in a particular direction. So for example, if there is a wall, and you're trying to push that wall, then you are basically applying a force on that wall. So that's how you define a force. But these definitions alone cannot give you a complete picture. You need to have some kind of units or some kind of quantity associated with these basic quantities. But that's how basic quantities work. Now, let's move towards idealization. So idealization is also a very important concept, which we're gonna use in coming lectures or when we're gonna do some examples. So idealization can also be called as modeling. So idealization or modeling is actually utilized to simplify the application of a theory. So for example, because real world is really complicated. For example, let me give you an example of this airport. For example, if you want to model this airport, then it has so many components in it. It has air recording components, it has different shape. So it would be very difficult to exactly model. But if we are studying something specific, then we can model this in the form of simplified idealization, and which we will study later, and it's going to become more clear to you. So in this subject, this idealization or modeling can be done in three parts. Either you can model it as a particle, or you can model it as a rigid body, or you can model it as a concentrated force. Now, different idealization or different modeling have different pros and cons, and it depends on the application. So what application you are going to have. So you have to model your object accordingly. So let us define these three modeling approaches. Particle. Now, particle is something that has a mass, but a size could be neglected. So it really depends on an application that you really want to ignore the size or not. For example, if I'm interested in if I drop this AirPod and it will fall onto my hand, and if I want to figure out like how much force this AirPod is going to apply on my hand, so basically I don't really need the size of this AirPod. I can really just model this AirPod as a particle, and then I can investigate how much push or pull it's going to apply on my hand based on the formulations which we're going to study later in this lecture series. So you can model it as a particle, but sometimes you cannot model anything as a particle. You have to model it as a rigid body. So rigid body is basically defined as a combination of particles that remain at fixed distances with each other. For example, you have particle and you have many particles. Now these many particles form a body. Now this body, if you want to model a complete body instead of a particle, then you can model it as a rigid body. And the idea of rigid body is that it has a mass, and it can also represent size. And we don't need to worry about these things now. We'll go into deeper details later in this lecture series. So concentrated force is also one of the modeling or idealization approach, which is used to represent the effect of loading at a point. So it is also used to represent force, and this is also very important modeling approach, which we're gonna use it extensively in this lecture. Okay, so now let's understand laws of motion, because they are also gonna come in handy later when we're gonna do numerical examples in the coming lectures. So what is the first law of Newton? Newton says that an object at rest remains at rest, and an object in motion remains in motion at a constant velocity and in a straight line unless acted on by an unbalanced force. So basically, what Newton is saying is that an object is at rest, then it's going to stay at rest. And if an object is moving with a constant velocity, it's going to stay moving, it's going to keep on moving with a constant velocity. So that's Newton's first law of motion. Pretty straightforward. Now, what is a second law? A second law states that an object acted upon by an unbalanced force will experience acceleration in the same direction with the magnitude directly proportional to force. So let us try to understand. The first law was an object is at rest, is going to stay at rest. Second law says that if there is an object and if there is an unbalanced force act upon that object, then an object will experience acceleration. That means that some object is at rest, you apply a push on it, then it will experience acceleration. That's the second law. Now, you can graphically see this. There is a mass and a force is being applied on that mass, and that mass is then experiencing acceleration. That's the formula, because the force, the higher the acceleration, the higher the amount of force, the higher would be the acceleration, and that's how Newton calculated this formula. Okay, so third law. Third law states for every action there is an equal and opposite reaction. The mutual forces of action and reaction between two bodies are equal, opposite, and collinear. Now, this is also one of the very famous third law that says that every action has an equal and opposite reaction. Now, let me try to explain this. For example, there is a wall, and there is one person who is applying a push on the wall. So if we want to represent these things, now a wall would be represented by a rigid body model, and a force would be represented by a concentrated force model. Now this is an action. Now every action should have an equal and opposite reaction. So these two forces would cancel each other out. Otherwise, if there is no reaction, then a force supposed to be start moving. Now, the mutual forces, action and reaction. So this is action, this is reaction between two bodies are equal. So they have to be equal in magnitude, by which I mean that these lengths should be equal, and opposite. This is directing this word, this is directing this word, and collinear. Collinear would mean that they are in the same line. So if there is a force applying on an object and object is not moving, that means that it is having a equal and opposite reaction, which is collinear. Now, we're going to understand all these things, and we're going to try to understand why collinear, why opposite in this lecture in detail later. But for now, you just have to basically understand what are these three laws, what are the idealization, what are these basic quantities. Okay. Now, the laws of gravity. Now this is also very important, because later when we will study forces and effect of forces on bodies, then we're gonna see this gravity force a lot. So let us define gravity first. So Newton says any particle of matter in this universe. So if there is one particle, this is another particle. Any particle of matter in this universe attracts any other particle with a force varying directly as the product of masses and inversely as the square of distance between them. Okay. So what does that mean? That means that if there is a particle and there is another particle, now these two particles, or if there is a third particle, all these particles attract each other. So they particles are going to attract each other. So let's just say this is a particle m1, this is a particle m2, and they're gonna attract each other by a force. So there is a force which is being applied onto each other, so they are attracting, and that force is directly as the product of masses. So that force is directly proportional to the product of masses. This is what this statement is saying. And inversely proportional to the square of distance between them. So let us say that the distance between them is r. So the force is inversely proportional to the square of distance between them. So Newton says that if we combine all these things, so Newton says that every particle in this universe attracts every other particle, and the force by which they attract is directly proportional to the product of their masses, which is written here, and inversely proportional to the square of distance between them. Now, you can remove this proportional and apply an equal sign, and then you have to replace with it with a constant. And this constant is g, which is called gravitational constant, and its value is also given because it's a constant value. Okay, so F is a force of gravity between two particles, as highlighted. G is universal constant of gravitation. M1 and M2 are the masses of each of the two particles. These two particles could be anything. Like, for example, one could be moon, another could be sun or earth, and r is the distance between these two particles. So that's how you calculate this formula. And what is weight? A weight is defined as a force exerted by an object. Now, why laws of gravity is translated into weight is, for example, let's just say you have a very big object. We call it Earth. I will designate this with M. And we have a very small object, maybe some satellite or maybe some building or anything. So this object would be called M. So they will attract each other. So since it has a bigger mass, so it's going to attract with a more force than this object. So this object has a small mass, so this object will experience what we call weight. So same here, you have a bigger object, you have a smaller object, the distance between these is r. So by the same definition, F is equal to G, and I will replace M1 with M, and I will replace M2 with capital M, R square. I can rewrite this because I want to figure out how much force is being applied on this small object, which would be the weight. So I will put M here, and the remaining is Gm over R square. I can replace this with G, which is called gravitational force. So this is F is equal to mg is the formula for weight, and F we can replace it by W to make it more sound like a weight. So that's how you calculate weight, and it's very important factor when we do numerical calculations later or study other factors of engineering mechanics statics. Okay. So let's move towards section 3. Now section 3 is important because we have studied those basic quantities like length, mass, time, but these quantities cannot give you a sense of magnitude unless you define these units. So units are basically used to measure a physical quantity. So in order to measure a physical quantity, you need to define some units. For example, you have a physical quantity mass, you have a physical quantity length, but how to know how much mass? What is a mass? So you need to define some kind of unit to get a sense of that physical quantity. And you're going to understand this more later. So units are divided into two types. One is SI unit and another is US customary unit. So SI unit is international system of units which is followed internationally in majority of the countries, and some country also follow US customary, which is basically mostly followed in United States, and it's customary system of units for United States. So let's see, there are these four basic quantities which we have gone through before. So I have put SI system units here and US customary units here. So we need some sort of unit to define these quantities. So length is usually in System International measured by meters and is written as M. Time is measured in seconds, written as S. Mass is measured in kg, written in kilograms, written in kg. Force is measured in Newton and written as N. In US customary, length is measured as a foot and is written as ft. Its time is same, and mass is measured as slug, and it's a derived quantity. So basically, if you know second, if you know feet, if you know pound, so you can derive the quantity for slug. And we're going to go through this also later in the medical examples. So force is measured as pound and it's written as lb. Okay, so just representing units is not enough. We also sometimes needs to assign prefixes. Now, what is a prefix? A prefix is a specifier or a mnemonic that is appended, attached to the units of measurements to indicate multiples of or fractions of units. For example, if I have multiples of fractions, for example, I have these are multiples, many multiples of kg. Kg is a mass. Or fractions, 0.00001, 0.000001 meter. It's a fraction of a unit. So it's very inconvenient to write it like this. Maybe there is a better way, and that better way is actually prefixes. So these are multiples, these are fractions. Now we can also write this in the form of exponential form. So in order to write in the form of exponential, we have to just count 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 zeros, so we can write it in the form of exponential like this, like 10, and there are 9 zeros, so we will put 9 to the power of 10. Now this is convenient, but we can also replace it with what we call prefixes. So 10 raised to the power 9 is called giga, and the SI symbol for giga is capital G. Similarly, we have these fractions 0.1, 2, 3, 4, 5, 6, 7, 8, 9. So since it's fraction, we can write 10 raised to the power minus 9, and the prefix for this is nano, and it's written as M. Now there are some rules which we need to follow for applying those prefixes. The number one rule is quantities are separated by a dot. So we have studied those quantities. For example, length is measured in meter, time is measured in second. So if we are combining those two quantities, we have to put a dot in between them. That's easier because meter is also a prefix milli. Milli is a prefix that stands for 10 raised to the power minus 3. So if it's written ms and there is no dot, that would mean that it's a prefix. It's not a quantity. So millisecond would means meter second because it's if there is a dot. So if there is a dot, then these if these are two quantities, then a dot would be applied on it. So quantities are separated by a dot. For example, you have two quantities, one is meter and one is second. So length is measured in meters and time is measured in second. If we put a dot in between them, then we'll understand that these are two different quantities. But if there is no dot between them, that would mean that the first letter is a prefix, it's not a quantity. So ms could also mean millisecond, or it could also mean meter second. So if we are putting a dot between them, then it means that these are quantities. And if we are not putting a dot between them, then it means that this is a prefix. Now, second rule is the exponential power on a unit also applies to the prefixes. For example, we have not put a dot in it, so that means that this is a prefix. So I have put nanometer square. That means that this power is also applied to nano as well. So actually it's this. We can also see here nanometer square would mean that there are 2 nanometer multiplying with each other. And also it's better to avoid prefixes in the denominator. So for example, Newton over, so we have not put a dot between them, that would mean that this is a prefix, but it's in the denominator, so it's better to avoid this, and instead of writing Newton per millimeter, you can write kilonewton per meter instead. And also it's better to use single prefix in the answer. In this case, there are different prefixes. So 3000, there is kilonewton and there is nanometer. So there are kilo also and nano also. So instead of putting this, you should use 3 millinewton meter, because then there will be only one prefix. So these are general rules which if you will follow, then it would be easier for you to understand the units. Now let us do some examples. Example 1 is convert 2 kilometer per hour to meter per second and then to feet per second. So meter per second is a system international unit and feet per second is US customary. Okay, so we can write 2 kilometer per hour as 2 kilometer over hour. So this kilo is a prefix, meter is a unit for length, and hour is a unit for time. So we have to convert it to meter per second. So kilo is a prefix, that means 1000 meter. So instead of k, we can just put 1000. So kilo, k is kilo, and kilo just means 1000. So instead of k, I will put 1000. 2, instead of k, I will just put 1000, because kilo is a prefix, that means 1000. An hour. So we also know that 1 hour has 60 minutes and 1 minute has 60 seconds, and second can be written as s in units. So 1 hour can be changed with 60 seconds. So we can write 2 into 1000 meter over. So 1 hour can be replaced by 60 into 60 into s. So 1 0 will go from here, 1 0 will go from here. So 220 divided by 6 multiplied by 6, 36 meter per second. So if you do the math, then you will come up with this number, 0.556. Now, so 2 kilometer per hour is equal to 0.556 meter per second. That's the answer, this one. Now we also have to convert it to feet per second. Now, in order to convert from system international to US customary, there are conversion factors which we need to remember. So this is something we have to remember. So 1 feet is equal to 0.3048. So 1 feet is equal to 0.3048 meter. So this thing can go there. So 1 feet over 0.3048 is equal to 1 meter. So basically what has happened is that this thing has gone to the denominator of the other equal side. So we can replace 1 meter with this thing. So that's what happened. 0.556 meter per second. So this meter can be replaced by 1 feet over 0.3048. So you multiply this by this. I mean, basically you have to divide this by this, and after dividing you're gonna come up with 1.82 feet per second, I guess. Okay, so this is one example. Now another example is we have to convert 300 pound second to SI units. Okay, so now this is US customary and this is SI units. So now again we need to, since we are converting from one system to another, we need conversion factors, which we unfortunately need to remember. So 1 pound is equal to 4.448 Newton. So we have 300 pounds per second. So instead of pound, we can write 4.448 Newton. So it would be 300 multiplied by 4.448 Newton over second. So if you multiply this with this, you're gonna come up with 1334.5 Newton second. Now remember, 1000 was equal to kilo, could be represented as K. So you can write it down as this. So this is the answer, and you also have a prefix. The third and final example is we have to evaluate this. So you have no dot, it means that this is a prefix and this is a prefix as well. And milli is a prefix which is represented by this. And giga is another prefix which is denominated by capital G and is written as 10 raised to the power 9. So 50 into 10 raised to the power minus 3 into 6 into 10 raised to the power 9 Newton. We can also write, we can do this, and now we can move this to here. So 50, sorry, I forgot to put Newton here. And Newton, if there is no power, you have power 1. So Newton can go here. So it would be 50 into 6 into 10 raised to the power 9. This 3 comes here. So you have minus 3 Newton. This one comes here. So you have 1 plus 1. So if you do the maths, you're going to come up with 300. 50 multiplied by 60 is 300. And 9 minus 3 would be 10 raised to the power 6. And 1 plus 1 would be 2. So that's what's written here. Now, since you have power 2 on basic quantity, so you also have to do something about this. So 300 into 10 raised to the power 3 into 2 into Newton 2. So this is common. So you can also write it as 300 10 raised to the power 3 Newton whole square. Now remember, 1000 was kilo. So you can replace it. I will just move it here, and you can replace it 300 kilo Newton square. And the square would also mean that you have a square here as well, as we have studied in the rules. So this is lecture 1, and see you in the lecture 2.